Okay, class, picking up where we left off at. It says, note in problem 1, the mixed number 1 and 1/3 represents 1 plus 1/3. So what do you think the mixed number in problem 2 represents? It represents 2 plus 1/2. So remember, it's always the whole number or the integer plus the fraction, and that will give you your answer. Okay, now it says identify each number as a proper fraction, improper fraction, or mixed number. Now we know this is a mixed number. This is a mixed number. Matter of fact, let's find all the mixed numbers if there are any. Okay, here's another mixed number. Okay, so we're done with the mixed numbers. Now, let's look here. 6 over 5. What type of fraction is this? Is it proper or improper? Okay, now since your numerator is larger than your denominator, we know that this is an improper fraction. So let's find all the improper fractions. Okay, remember improper fractions, it has to be larger or the same as the denominator. So number 5 is also improper. And also number 7. Okay, now we look here. We have all of our numerators is less than our denominators. So this will be called a proper fraction. And this is a proper fraction. And this is a proper fraction. Now it's very important that you know the difference between the two. Between these three, because if you're dealing with a proper fraction, you know that's less than 1. If you're dealing with an improper fraction, you know that's greater than 1, and a mixed number is greater than 1. Okay, now we scroll down here. It says represent the shaded part of each figure group's area as both an improper and a mixed number. Okay, first of all, this figure is cut up, and these are two separate figures that are cut up to be the same amount of equal parts. We have 1, 2, 3, 4 equal parts. So we know our denominator is going to be 4. Our numerator is all of the shaded parts, which is 1, 2, 3, 4, 5. So this is the improper fraction. Now we want to write it as a mixed number. What we could do is this here. We could write what we see. We have one whole that's shaded. And then we know our denominator is 4, and our numerator would be the extra that's shaded. So it'll be 1 and 1/4. So 5/4 is your improper fraction. 1 and 1/4 is your mixed number. Now we come here. We look at these figures here. 3 separate figures cut up. So and they cut up in equal parts. So this is cut up into 3 parts. So our denominator would be 3. Now we want to do our numerator. We have 1, 2, 3, 4, 5, 6, 7, 8. So our numerator would be 8. Now that is the improper fraction. Now we want the mixed number. So we look here. We have 2 shaded figures shaded all the way. So we know that our whole number would be 2. And we know for our fraction, our denominator would be 3. And our numerator would be what's left over, which is 2. Left over as far as being shaded. So 8/3 and 2 2/3 is the answer for number 2. Now we go to section D, write in mixed numbers as improper fractions. The following steps may be used to write a mixed number as an improper fraction. Okay, first of all, step 1, multiply the denominator of the fraction by the whole number. Step 2, and instead of whole number, we could put by the real number. Step 2. It says add the numerator of the fraction to the product from step 1. Step 3, write the sum from step 2 as the numerator of the improper fraction over the original denominator. Actually, you know what? I shouldn't have put real. I should have put integer, because we would not have any decimals here. So it would be the integer by the integer. Okay, now, for example, we have 1 and 2/3. So what we would do is we would take this denominator times this integer. So we add 3 times 1, and then we would add the numerator. So and keep our denominator the same. So we know according to the order of operations, we'll do multiplication before addition. 3 times 1 is 3, plus 2, all over 3. 3 plus 2 is 5, and that's over 3. So it's 5/3. Now we're going to try some problems here. Now this first problem. The first thing we should know is our denominator will still stay 7. Now our numerator, we'll take 7 times 2 plus 5. Remember, we'll take this denominator times the integer plus the numerator. 7 times 2 is 14 plus 5 all over 7. 14 plus 5 is 19 over 7. So that would be your final answer. Now we come to number 2. Same thing, our denominator would stay 3. Our numerator would be 3 times 5 plus 1. 3 times 5 is 15 plus 1 all over 3. 15 plus 1 we know is 16, and that's divided by 3. Now we come here to number 3. Again, our denominator stays 10, and our numerator would be 10 times 9 plus 3. 10 times 9 is 90 plus 3 all over 10. So our final answer here is 93 over 10. Now we come here to number 4. Our denominator stays 5. And our numerator, we have 5 times 1, 5 times the integer, plus the numerator. So this will give us 5 plus 1 all over 5, which is 6 over 5. Now let me tell you all this here. When you're doing these type of problems, because they ask you to write it as an improper fraction, you do not rewrite this as a mixed number. They wanted you to go from a mixed number to an improper fraction. Also, later on you will get that later, but I want to do one other thing here. I want to create another example, and I'm going to write this off to the side. This would be number 5. Now first, why don't you watch this, and then you can see where you could place number 5 depending on how much room you would need, and then you could just rewind it. Say number 5 was -1 1/5. Let me make it easy here. And we wanted to change this to an improper fraction. So this is what you would do. You would start it off the same. Your denominator would stay 5. And you would keep your negative symbol on the outside here. Now your numerator, when we multiply, we are not going to bring the negative sign up here to the top. We're going to leave it out here in the middle. So we would take the denominator of 5 times 1 plus 1. So we would do this the same, but just carry over our negative symbol. 5 times 1 is 5, plus 1, all over, it's supposed to be all over 5. Now, we'll carry over our negative. Remember, this negative is not with the 5. What's 5 plus 1 is 6, and our denominator stays 5. So this will end up being -6/5. Now again, we had -1 1/5. The negative, we just kept carrying it over. But when we multiplied and added here, we did this without the negative. So it became 5 plus 1, which was 6. So we got 6 over 5, and we carried over the negative symbol. Now, if you look at example 4 and example 5, the only difference between these two is that you carried over the negative. You still did the multiplication and addition exactly the same. You just carried over the negative sign. And you're only doing this when you're changing a mixed number to an improper fraction. Now, let's scroll down here. It says section E, write in improper fractions as mixed numbers or whole numbers. Okay, the first one, step 1, divide the denominator into the numerator. Step 2, the whole number part of the mixed number is the quotient. The fraction part of the mixed number is the remainder over the original denominator. Now, I think you will understand this a little bit more when I actually do a problem. Let's scroll down here. Well, it actually shows a representation here. Now, it says to change an improper fraction to a mixed or whole number, we start by identifying the numerator and denominator, which we have here. Then translate the fraction into a traditional division problem. So it'll be 3 and 5. Now, we ask ourselves here, how many times does 3 go into 5? It goes in once. 1 times 3 is 3. And we know this is subtraction. So you could put a little minus there on your paper. 5 minus 3 is 2. Now, this 2 is actually the remainder. I know they didn't write it here, but you could write that in. This 2 is actually the remainder. So it's 1 remainder 2. So what we would do is this. All of the numbers that are in front of the remainder, which is 1 here, that goes in the place of the integer of this mixed number. Now the remainder, now if you notice, your denominator here did not change. It stayed the same. So in front of the remainder, that would be your integer. Your denominator will stay the same. Now for your numerator is the number behind the remainder, which happens to be 2. So that is how you would write that. Now, let's try a problem. We had 9/5. So we would take 5 into 9. 5 goes into 9 one time. 1 times 5 is 5. 9 minus 5 is 4. Now, we will have a remainder of 4. So our integer would be 1. Our denominator would stay 5. And our numerator would be the number after the remainder, which would be 4. So it'll be 1 4/5. Now we go here to number 2. You would take 9 into 23. 9 goes into 2 0 times. 9 goes into 23 twice. 2 times 9 is 18. So we add 23 minus 18. We know we cannot subtract 8 from 3. So we'll borrow 1 from this 2. And this 3 will become 13. 13 minus 8 is 5. And we know 1 minus 1 is 0. So it'll be 2, remainder 5. So our final answer would be 2, would be the integer. Our denominator would stay the same, which would be 9. And our numerator would be the remainder, which is 5. So it'll be 2 5/9. Now, we scroll down here to number 3. We would take 4 into 48. 4 goes into 4 once. 4 minus 4 is 0. We'll bring down our 8. 4 goes into 8 twice. 2 times 4 is 8. And we had no remainder. So your answer would just be the whole number 12. Now we have 62 divided by 13. So we'll take 13 and a 62. 13 goes into 62 4 times. 4 times 13 is 52. You have a remainder of 10. So your final answer here would be 4, 10 over 13. Now we go to number 5. We have 7 into 51. 7 goes into 5 0 times. 7 goes into 51 7 times. 7 times 7 is 49. We know we cannot subtract 9 from 1, so we borrow 1 from this 5, makes it a 4, and this 1 becomes 11. 11 minus 9 is 2, and 4 minus 4 is 0. So you have a remainder of 2, and your final answer would be 7. Your denominator would be 7, and your numerator would be 2. So it would be 7 and 2 7s. Now we come to number 6. We'll take 20 into 21. We know 20 goes into 21 only one time. 21 minus 20 is 1, so your remainder is 1. So your final answer, the integer would be 1, your denominator would be 20, and because 1 is after your remainder, 1 will be your numerator. So it's 1 and 1/20. Now, we scroll to the next page. Extra practice. It says fill in the chart, converting between the mixed number form and the improper fraction form of each number. So we know, first of all, our denominator would be 3 here. Our numerator would be 3 times 5 plus 2. Now we know 3 times 5 is 15 plus 2 over 3. 15 plus 2 is 17, all over 3.